Which of the following are considered as disadvantages of Gauss-Seidel method over Newton's method in load flow programs? Explanation: one of the disadvantages of the Gauss-Seidel method compared to Newton's method in load flow programs is that it often requires more iterations to converge to a solution. While Gauss-Seidel is a simpler iterative method, it may take longer to reach convergence, especially for complex power systems. Hint for students: Gauss-Seidel is a simple iterative method, but it may require more iterations to converge compared to the Newton-Raphson method. 3. The quantity Rm which relates dependent voltage to controlling current is called. Explanation: the quantity Rm in the context described relates the dependent voltage to the controlling current and is known as transresistance or transfer resistance. It characterizes the relationship between the input current and the output voltage in a device or component, often encountered in semiconductor devices like transistors. Hint for students: think of transresistance as the relationship between current and voltage in a device. It's like the electrical equivalent of resistance for current-controlled devices. 4. For which purpose bundled conductors are employed to a power system? Extended: the primary reason for using bundled conductors in a power system is not to increase the short-circuit current. Bundled conductors are mainly used to reduce the line inductance and skin effect, increase the transmission capacity, and improve voltage distribution along the line. They are often used to improve the mechanical stability of the line, making option B a more appropriate answer. Here's a breakdown of why the other options is incorrect. A. Appearance of the transmission line: while aesthetics could be a consideration, it is generally not a primary reason for using bundled conductors. C. Decreased system stability: contrary to this, bundled conductors are typically used to improve system stability, not decrease it. D. Increase the short-circuit current: bundled conductors might slightly influence the short-circuit current, but that's not their primary function. Explanation: bundled conductors are primarily used in high-voltage transmission lines to reduce the corona discharge and its associated losses. Corona discharge is the ionization of the air surrounding the conductor, which can lead to power loss and interference with communication systems. By using bundled conductors, the effective diameter of the conductor is increased without a significant increase in the weight of the line, which helps reduce the corona effect. They also improve the transmission line's mechanical stability, especially under adverse weather conditions. Hence, the correct option would be B, mechanical stability of line, but the primary reason for using bundled conductors is to reduce corona discharge and its associated losses. Hint for students: think of bundled conductors as strands of hair. One single hair can easily be broken or get frizzy, akin to corona discharge. But when you bundle multiple strands together, they become stronger and less prone to getting frizzy. Similarly, bundled conductors offer strength and reduce the corona effect in transmission lines. 5. Radio frequency chokes are air-cored too? Explanation: radio frequency chokes are air-cored, also known as air-core inductors, to keep their inductive reactance low at radio frequencies. This low inductive reactance allows them to effectively block or filter out high-frequency signals while allowing lower-frequency signals to pass through. Air-core inductors are preferred in radio frequency applications because they minimize losses and maintain the integrity of the high-frequency signals. Hint for students: radio frequency chokes use air cores to keep their inductive reactance low, making them effective for filtering high-frequency signals in RF applications. 6. The fundamental property used in single-node pair circuit analyzer is that across all elements is same? Explanation: in a single-node pair circuit analyzer, the fundamental property that is used is that the voltage across all elements connected to the same node, or point, in the circuit is the same. This property is based on Kirchhoff's voltage law, KVL, which states that the algebraic sum of the voltage drops in any closed loop of a circuit is equal to 0. In a single-node pair, there are no closed loops, so the voltage at that node is the same for all connected elements. Hint for students: in single-node pair analysis, the key property to remember is that the voltage across all elements connected to the same node is equal. This property simplifies circuit analysis.